The graph of y equals f of x is shown on the grid. And we are asked on the grid, draw the graph where equation y equals f and in brackets x plus 1 minus 3. If we compare the two, originally I had y equals f of x, that's the one drawn. And I'm asked to draw y equals f and in brackets x plus 1 minus 3. So what has changed is inside the bracket, we've now got this plus 1. What we should realise is inside the bracket applies to x, it's with the x, but it does the opposite. So instead of adding 1, it's actually going to subtract 1 for each of our x values. So it's going to be a translation by 1 unit in the negative x direction. Also looking at our function, in this case here we can see we've also got minus 3 appear on the outside. If we've got something on the outside, outside applies to y and does exactly what it says. So in this case, negative 3 means it's going to translate the graph down by 3 units in the negative y direction. We now get our tracing paper and trace over our original graph of y equals f of x. So for x, I'm going to translate my graph negative 1 in the x direction. So I'm going to move 1 square to the left, the negative x direction, like so. I'm now going to look at my y. For y, it's going to drop it by negative 3. I'm going to move the graph down 3 squares in the y direction, 3 squares down. So 1, 2, 3. Press hard over my tracing paper to reveal my new graph. We're now told the point A, negative 2, 1, lies on the graph y equals f of x. That was our original graph, y equals f of x. That's our point A, negative 2, 1. When the graph of y equals f of x is transformed to the graph where equation y equals f and in brackets negative x, point A is mapped to point B. Write down the coordinates of point B. Well, if there's a negative inside the bracket, we know a negative inside the bracket means a reflection in the y-axis. So therefore, negative 2, 1 reflecting the y-axis would now become positive 2, 1. So the coordinates of B would be positive 2, 1.